homework time. Happy homework time is here again. Let's start in the usual way, jotting our name down at the top of our paper. Here's the dealio. I'll put my name, you put yours, and then for today's date, I will simply write today, which it is. That's correct, but you write the actual date, where and when you are in this universe. Our instructions for all of these word problems. See, last time we got off with no word problems. I have a feeling we'll be doing quite a few tonight. So solve the following problems. Draw tape diagrams to help you solve. That's not a suggestion, by the way. We're actually going to draw them. Identify if the group size or the number of groups is unknown. Okay, so this is worth understanding, this distinction between the size of the groups or the number of the groups. So let's just look at it in practice here. So number one asks us 500 milliliters of juice was shared equally by 4 children. How many milliliters of juice did each child get? So what we know here is that we have 500 milliliters, right? That's our total. That's why I'm putting it for the whole thing. And notice again, I just want to point out milliliters, the L is capitalized as it is for liters, so it doesn't look like a 1. So 500 milliliters. Now I'm going to be sharing it with 4 children. When you have a rectangle, and this will be useful when we get to fractions and decimals, the bells! Okay, we split it in half. Just going to talk over that. Hey, this is a real life school, y'all. There's bells. And then split each half in half. And that gives me 4 relatively equal portions. So what I'm trying to solve for here is how much juice does one child get? We'll call that C for child, because being shared by 4 children. And so so there's my tape diagram. Am I trying to figure out the number of groups? Well, by groups we mean, how many partitions are here? How many divisions? Well, I have 4 partitions, right? I have 4 parts to this. So I know how many groups. There's 4. There's 4 children here I'm sharing it with. So the size of the group is what I'm trying to find. How much juice? So we are trying to find, so we are solving. I'm just going to write it this way. Solving for group size. And I realize the word group is possibly a little confusing because there's no groups here per se. But we know the number of groups. That's the number of children. Okay, so let's do the actual math. So we have 500 milliliters. We can see from our diagram and just from our good old brains that we are dividing this among 4 children. So how many 4s in 5? Yep, there's 1 because 1 times 4 is 4. This is getting so easy now, isn't it? Subtract, you get 1. And now we have 0 tends to divide. Treat 0 like any other number, I keep telling you. How many 4s in 10? There are 2, because 2 times 4 is 8. When we subtract, we get 2. And now we can divide up the 0 1s as well. How many 4s in 20? There are 5 4s in 20, because 5 times 4 is 20. When we subtract, we're left with 0. So we have no remainder, and we're not instructed to check, so we won't. All right, so let's write, though, an answer to the question, which is how many milliliters of juice did each child get? Each child received, and I prefer received to get. I don't know, I had a librarian when I was in middle school who just loathed the word get, and really made an impression on me that very often you can choose a better word. For example, if you're buying something, you wouldn't necessarily say, I got a shirt. You'd say, I bought a shirt. Or you'd say, my mother bought me a shirt. I don't know. Picky like that. Each child received how much? There's our quotient. That's how much each child received. 125 milliliters of juice. And this is a real word problem. If you ever work at a summer camp as a counselor, you might have to say, okay, I have 30 kids in this cabin, and I have these gallon jugs of bug juice, and you can't just start pouring. You get to the last 5 kids and they get nothing. Then you got problems, yo. Gotta divide. All right, so let's go on to number 2. Well, it must have been snack time in Eureka Math Land when they were writing these questions. This is another one you might run into as your camp counselor future career in your high school summers. Kelly separated 618 cookies into baggies. Each baggie contained 3 cookies. How many baggies of cookies did Kelly make? I mean, you might actually do this. You might have boxes of cookies and you just start bagging them up, 3 each for the kids, and then you say, gosh, do we have enough bags of cookies here, or baggies, as they say. I don't know where we get baggies from, but do we have enough baggies of cookies? And you just, instead of counting them, which will take a long time, be prone to error, you just do the math. So now we know that we know how many cookies we have in all. Right? The whole tape here is 618 cookies, right? And then what we have is, and this is the way they draw it in Eureka Math, we don't know how many baggies we have. So we're going to do this. We're going to draw, hey, we're dividing it up. And I'm doing this little ellipses, dot, 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 to indicate there are more divisions, but I don't know how many, and there's probably too many to draw anyway. What we're trying to find here is this. No, we know that, don't we? We know, yes, we know that there's 3 cookies in each baggie. We're trying to find how many baggies. See, so we know how many in each group. We know the group size is 3. We don't know the numbers of groups. So we are solving for number of groups. How many baggies are there? Okay, so that's why we have this dot, dot, dot. So you'll see a certain pattern as we go through. So again, we know it's division because we have 618 cookies and they are being divided into baggies of 3. So how many baggies are there? Well, how many 3s and 6? 2, because 2 times 3 is 6. I'll tell you, division's the easiest part of this nowadays, huh? Subtract, you get 0. We then have 1, a little trick here, watch this, 110 to divide. So I'm sitting there, I have, getting off the cookies for a moment, but I have 1 box of donuts and 3 people, and they're saying, hey, how many boxes do we get each? I say, you get 0 boxes each. I'm going to have to open it up because 0 times 3 is 0, so I still have that box, which I'm going to decompose and combine with the 1s. So now I have 18 1s I'm going to divvy up. In this case, cookies, but I'm going back to my donut thing. So 3, how many 3s and 18? There are 6, we know, because 6 times 3 is exactly 18. So no groups left over, which is good because that would be confusing. And so 206 tells us how many baggies of cookies, a bit of a tongue twister, Kelly made. So Kelly made, you see how it's the number of groups, the number of baggies? 206 baggies. And I could say of cookies, but I'm feeling a little lazy, so I won't. Let's go on to number 3. And in number 3, we're kind of off the camp counselor thing. We're on to Jeff and his biking. Go, Jeff. So Jeff biked the same distance for each day for 5 days. So 5 days biking the same distance each day. If he traveled 350 miles altogether, how many miles did he travel each day? So again, we know the total. So when we start off drawing our tape diagram here, this tape is the total. It's 350 miles, which we abbreviate MI. Now, he did that for 5 days. So if I partition this to 5 parts, right, that would show 5 days. 5 is a little trickier to do. You have to draw 4 lines that are kind of equally spaced. So 1, 2, 3, 4. And those are approximately equal. Good enough. Now, I know I have 5 groups, right? 5 days. What I don't know is this. This is how much the distance for one day. So we'll call that D for distance day. So we know the number of groups. We don't know the size of the group. So solving for size of group. Okay, you see how the 5 days is the number of groups, and we need to know the size of each. So let's do that. So we have 350 miles, and you can easily see its division. Don't just assume it is, because hey, we're doing division. You have to think about it. We have 350 miles that's divided across 5 days. So how many 5s in 35? Indeed, there are 7, because 7 times 5 is 35. Subtracting, we have 0, but we still have 0 ones to divide. Treat it like any other number. How many 5s and 0s? There are 0 5s and 0, because 0 times 5 is 0. Subtracting, we of course are left with 0. See, if you left that step out, you'd end up with 7. That doesn't make sense, right? Because that would mean 35 miles, not 350. Big difference for Jeffrey. Okay, so now that's the size of the group, so 70 miles per day. How many miles did he travel each day? Jeff, ardent bicyclist that he is, Jeff traveled 70 miles, and I can use a slash here, 70 miles per day. Go, Jeffrey. All right. Speaking of going, let's go on to number 4, around in the bend, past the midway point of homework time. All right, number 4, so we went from like juice to cookies to bicycling, and now we're talking about a factory and ribbons. All right, so there we go. No continuity here. A piece of ribbon, 876 inches long, was cut by a machine into 4-inch long strips to be made into bows. How many strips were cut? So we know the total length, right? The whole ribbon is how long? Is 876 inches, which we abbreviate IN. And so now we know how long each strip is. Each strip is 4 inches. So 4, 4, like I'm cutting up the ribbon here. 4, 4, 4, and so on. So I have my dot, 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 meaning ellipses is what it's called, meaning and so on, continuing. I do know how long each strip is, right? That's 4 inches. I'll write it, why not? I don't know how many strips though. So I know the size of each strip, but not how many strips. I know the size of the group, but not how many groups. So we're solving for number of groups. And your teacher will be so impressed that you wrote this for every single example. They will give you a big pencil. Okay, so let's go ahead and do the math. We have, and you can see its division because just like we did in our drawing, we're actually cutting it up, physically dividing it. 876 inches divided into 4-inch strips. So how many 4s in 8? There are 2 because 2 times 4 is 8. Subtracting, of course, we get 0. Go to the tens. There are 7 tens. How many 4s in 7? There is 1 because 1 times 4 is 4. Subtracting, we get 3. Am I going too fast for you? I can go slower. And we have 6 ones to divide here, so 36 ones altogether. How many 4s in 36? Ooh, you know that one? Because 4 times something is 36. I'll give you that little hint. That's right, 9. 4 times 9 is 36. Subtracting, we're left with 0, which is good not to have a remainder here. That would be confusing. So 219 strips were cut. Okay, and using the passive voice. 219 strips were cut. Answers the question. Beauteous! Can you believe we're already on to the last one next? Number 5. Let's do it. I tell you, sometimes I worry about the people who write this stuff. Like we started off with juice, went on to cookies, riding a bicycle, and like strangely we're cutting ribbon on a machine. Okay, I'm down with that though. Now we're on to weirdness. This one's like surreal, psychedelic question. This is probably the single weirdest question in all of 4th grade Eureka Math. I don't know, it just comes out of nowhere. 5 Martians, right there, 5 Martians, equally share 1,940 Groblark's fruits. Yes, they did. So how many Groblark's fruits will 3 of the Martians receive? Okay. Okay, Eureka people. All right, so we know how many fruits. Let's just say we have, so we know the total amount of Groblarks, the whole thing here, is 1,940 Groblark's fruits. And we know we have 5 Martians, so that's 1, we can draw 4 lines in here, 2, 3, 4, and that gives us our 5 Martians. There we are. See, so you can see right here, 1,940 fruits being split among 5 Martians, divided equally among the 5. And so in order to, what we're really trying to find is answer the question, how many will 3 of them receive? But we're going to first have to, of course, solve for 1. Okay, so we'll call this F for how many fruits will 1 get. But I want to include in my tape diagram here, just to be clear, what I'm really trying to solve for is this. How many fruits will 3 of the Martians receive? And I'll call that T for 3. Why not? Okay, so we see this is a multi-step problem. First one we've had in a while, all right, since we did multiplication, I believe. All right, so if we take our fruits and start handing them out to Martians, we'll be able to do that. But first, we know how many groups, don't we? We have 5 groups we're putting them into because we have 5 Martians. So the question is the size of the group. How many fruits will each receive? And then how many will 3 receive? So we're solving for size of group. And see, when you draw a tape diagram first, that's obvious, okay? So let's do the math. We have 1,940 Groblarks, fruits, and we have 5 Martians, okay? Because that's how I'm divvying them up. I can't divide it by 3. That will not give me the right answer. Because when you look at this, the 1,940 goes to all 5 of them, not just to 3 of them. I have to find out first how many fruits 1 Martian receives, then I can solve for 3. So how many 5s in 19? Well, you got it. Yep, there are 3 because 3 times 5 is 15. When we subtract, we are left with 4, which we combine with the 4 tens, so 44 tens. How many 5s in 44? Ooh, we done one? Yep, 8. There are 8 because 8 times 5 is 40. Subtracting, we're left with 4, and let's treat 0 like a number, as I keep telling you. We have 0 ones that need to be divided up. How many 5s in 40? Well, we just did that. Yes, we know there are 8. So 8 times 5 is 40, and I'm glad we don't have a remainder again. That would make things a little confusing. So we are left with 0. So each Martian, that's our F here, so I'm actually going to write that in, equals 388. So that I can see what I'm trying to do is, oh, okay, so if 1 Martian gets 388 fruits, then I want to solve for 3. If I take that 388 Ah, yes, and multiply it by 3, that would give me the grobblearks for 3 Martians. I bet some of your classmates will miss this step. Poor little fellows, they should be watching my videos. All right, so 3 times 8 is 24. Yep. And then, once again, 3 times 8 is 24, but this time plus 2 is 26. 3 times 3 is 9, plus 2 is 11. I just want to make sure that kind of makes sense, right? It shouldn't be more than this. Like 3 of them can't get more fruit than I have in all, and they couldn't get less than 1 Martian gets. Okay, I just want to make sure this answer makes sense. And this is about 400, which tripled would be 1,200. This is in the 1,200 neighborhood. Okay, I'm good. So 3 Martians receive this many grobblearks fruits. So 3 Martians receive, and see they use receive here instead of get, receive 1,164 fruits. Boom! Look at that! You done it! You completed another homework time. I'll see you again next time. It is homework time.